In this video, we are going to learn how to factor completely using the techniques we have learned in the previous videos. Step 1. Always check first to see if there is a greatest common factor. If there is, factor out the greatest common factor. Place the other factor in parentheses. Step 2. Decide if you have a difference of two squares, or a trinomial in the form x squared plus bx plus c. If you do, continue to factor the factor that's in the parentheses using these methods. Note, be sure that your final answer contains all the factors, including the greatest common factor. If you cannot do any type of factoring with the expression greatest common factor, difference of squares, or factoring a trinomial, then the expression is prime. Example 1. Let's look at these two terms. Notice there is a greatest common factor of 2 in both of the terms. So what we will do is factor the 2 out. We'll put the 2 outside of the parentheses, and we'll write the terms inside of the parentheses, dividing them by the greatest common factor, which is 2. Then we will simplify what's inside the parentheses. 2 divided by 2 is equal to 1, so we're left with x squared. And 162 divided by 2 is equal to 81. Now let's look at what's inside the parentheses. X squared minus 81. I'm going to write just that part over here, and let's see if there's something we can do to factor that. This binomial is in the form a squared minus b squared. Our a squared is x squared, and our b squared, what squared gives us 81? 9. So we can write 81 as 9 squared. So our a is equal to x, and our b is equal to 9. Recall, this is factored as a plus b times a minus b. So we'll use that to factor x squared minus 9 squared as x plus 9 and x minus 9. So now we have to go back and put that as the factored form of what's in the parentheses here. So our final answer for the factored form of our original problem is 2 times the quantity x plus 9 times the quantity x minus 9. Example 2 has a greatest common factor of x. Notice there's x to the third in the first term and an x to the first in the second term. So the smallest power we have is x to the first. So that is what we can take out of both of these terms. So we will write the x on the outside of the parentheses, and then inside the parentheses we will divide the terms by the greatest common factor, which is x. Next, we will simplify inside the parentheses. When we divide, we subtract the top exponent minus the bottom exponent. X has an exponent of 1, so we subtract 3 minus 1 to get x squared here, and then x over x divides out and becomes 1, and 4 times 1 is just 4. So now we have a binomial inside the parentheses, and we can factor that. So I'm going to write what is inside the parentheses over here, and let's work on that. X squared minus 4 is in the form a squared minus b squared. We can write this as x squared minus 2 squared. So our a is equal to x, and our b is equal to 2. So we can factor this as x plus 2 times the quantity x minus 2. Then we will go back to our original problem that has the x that we factored out first, and we'll rewrite what was in the parentheses as x plus 2 times x minus 2. So that is the factored form. Our next expression, we have 3x cubed minus 27x. Let's look at the coefficients first and see that there's a greatest common factor of 3. Both terms also contain x to the first, so we can take a 3x out of both of these terms. So inside the parentheses, we'll write the terms divided by the greatest common factor. And then we'll simplify what is inside the parentheses. So the 3 over 3 divides out and we get 1. Remember, we have a power of 1 on that x. So x to the third over x to the first, we subtract the exponents and get x squared. 27 divided by 3 is 9, and x divided by x is 1, and 1 times 9 is 9. So now let's look at what's in the parentheses and see if we can factor that some more. We have x squared minus 9. This is in the form a squared minus b squared, because 9 can be written as 3 squared. So our a for this polynomial is equal to x, and our b is equal to 3. So we will factor this by using the formula for difference of squares, a plus b times a minus b. So we get x plus 3 times x minus 3. Then we'll go back to our original problem and replace what's in the parentheses with its factored form of x plus 3 times x minus 3. In this expression, we have a greatest common factor of x. So we will factor the x out and divide the terms in the parentheses by the greatest common factor. Then we'll simplify inside the parentheses. Recall that this x has a power of 1, and when we divide, we subtract exponents. So 2 minus 1 is equal to x, and our x's divide out here, and we get 25. And now our factored form at this point is x times the quantity x minus 25. This parenthesis has x minus 25. This is not in the form of a squared minus b squared because the x is not squared. So this piece right here cannot be factored. It is prime because our a is not a perfect square. So this is our completed factored form for this problem, and there's nothing more that we can do. Here we have a trinomial. We need to look to see if there's a greatest common factor in all three of the terms. Let's look at the coefficients. 2, 10, and 12 are all divisible by 2. So 2 is the greatest common factor. The x's are not in every term. We only have the variable x in the first two terms. So x will not be part of the greatest common factor. So what we'll do is we'll factor out a 2. And then we'll simplify what's in parentheses by dividing each term by 2. Next, we're going to simplify. 2 divided by 2 is 1, so we're just left with x squared. 10 divided by 2 is 5, so we get 5x. And 12 divided by 2 is 6. Next, let's take a look at this trinomial, x squared plus 5x minus 6. This is in the form x squared plus bx plus c. So let's see if we can factor using our riddle where we need to multiply two numbers to get C, but add those same two numbers to get B. So let's list our factor pairs of -6. We can multiply -1 times 6 or 1 times -6. -2 times 3 or 2 times -3. These are all the ways that we can multiply to get -6. Which pair, when I add them together, equals +5? This one does. -1 times 6 is equal to -6, and -1 plus 6 is equal to 5. So the factored form of this trinomial, using our magic numbers that we found by solving our mathematical riddle, we get x minus 1 times a quantity x plus 6. Then we go back to our original problem and we replace what was in parentheses by its factored form of x minus 1 times a quantity x plus 6. Our next problem, we ask ourselves if there is a greatest common factor. The coefficients are 1, -1, and -20. The greatest common factor here would be 1, which is not something that we need to factor out. But if we look at the x's, we can see that each one of them has at least x to the first. So we can factor out an x in each of the terms. So let's put the x on the outside and write our trinomial dividing each term by the greatest common factor. Next, we will simplify what's in parentheses. Remember that an x has a power of 1. So we subtract exponents when we divide. 3 minus 1 is 2. So we get x squared. 2 minus 1 is 1. So we just get x to the first, or just x. And x over x is equal to 1. So we're just left with 20 as our last term in the parentheses. Then let's look at what is in the parentheses and see if we can factor that. We have a trinomial in the form of x squared plus bx plus c. Our c is equal to -20. So we need to find factor pairs of -20 that add to give me b. Now what is b? What number is in front of that x term? It is a -1. So we need to find factor pairs of -20 that add to give -1. So let's find factor pairs of -20. So we can do -1 and 20, and 1 and -20. -2 and +10, and +2 and -10. Multiply to give us 20. 3 does not divide 20. 4 does, so let's do -4 and +5 and +4 and -5. And that is our completed list of factor pairs of -20. Which factor pair, when I add them, equals -1? This one is 4 plus -5. 4 times -5 is equal to 20, and 4 plus -5 is equal to -1. So using the numbers we determined using our number riddle, we will write our factored form as x plus 4 and x minus 5. So bring that back over to our original problem and replace what's in the parentheses with its factored form of x plus 4 times x minus 5. In our next expression, let's see if there is a greatest common factor. 3, 6, and -15 are our coefficients, all of which are divisible by 3. So we know that 3 is part of the greatest common factor. Each of the terms also contain at least x to the first, so we can take out x to the first out of each of these terms. So x to the first is part of our greatest common factor. Then we will write the terms inside the parenthesis, dividing them by the greatest common factor. Next, we will simplify what's inside the parentheses. 3 over 3 is equal to 1. And we will subtract our exponents, the top exponent minus the bottom exponent. 3 minus 1 is 2, so we get x squared. 6 divided by 3 is 2. And 2 minus 1, so we're subtracting our exponents, top minus the bottom, is x to the first. And our x's here divide out, and we get 15 divided by 3 is equal to 5. Now let's see if we can factor the trinomial that's inside the parentheses, and we'll do that over here. It is in the form x squared plus bx plus c, so we will solve our number riddle. Where c is negative 5, I need factor pairs of negative 5 that add to give me b, which is 2. So let's come up with our factor pairs of negative 5. So we can do 1 and negative 5, and negative 1 and 5. That is all the factor pairs we have for negative 5, neither of which add to give us positive 2. So in this case, this part of the problem is prime, so we can't factor this any further. But our original problem isn't prime because we could factor out the 3x. So this is our factored form of our problem. 3x times the quantity x squared plus 2x minus 5. This problem has a negative in front of the x squared term. Recall to factor trinomials in the way that we've learned in this chapter. The coefficient in front of the x squared term must be 1. In this case, it's a negative 1. So in order to factor this further, we need to factor out a negative 1 from all of the terms. So we'll put a negative 1 on the outside of the parentheses. And what we ask ourselves is, what should we write here so that when we multiply by negative 1, we get negative x squared? That would be positive x squared. What number, or what do we multiply times negative 1 to get negative 5x? Well, that would be positive 5x. What can we multiply times negative 1 to get positive 14? Well, that would be negative 14. Notice that when we factor out a negative 1, each of the terms inside the parentheses will have the opposite sign of the original expression. Now, let's factor what's inside the parentheses. This is in the form x squared plus bx plus c. We'll set up our number riddle where c is negative 14 and b is equal to 5. We need factor pairs of negative 14. Let's list them. 1 and negative 14. Negative 1 and positive 14. 2 and negative 7. And negative 2 and positive 7. Which factor pair adds to give me positive 5? Well, negative 2 plus 7. Negative 2 times 7 is negative 14, and negative 2 plus 7 is equal to 5. So our factor form here, using our magic numbers, are x minus 2 and x plus 7. We'll go back to our original expression and replace what was in the parentheses with its factored form. So the factored form is negative 1 times the quantity x minus 2 times the quantity x plus 7.